Hello folks, I am Ritika. Today we are going to begin with the topic exponents and power. So before jumping into the theory, let's just hang around some basic things that revolve around exponents and power. So have you ever thought about a number that is probably difficult for you to read or pronounce? Now, let's say we have the number 100 that we know is 100. If we increase 10, it becomes 1000. That is of course to be read as 1000. We put another one, it becomes 10,000. Now, putting on 2 more zeros altogether, we receive 1,000,000. 3 more and we get 1,000,000,000. So, what if we kept on increasing the set of zeros like this? Not only would the unending number of zeros create a star of confusion, but if we are interested in operating some of these numbers altogether, they would definitely be complex to deal with. But we are mathematicians. Such tender issues don't deter us from finding a solution to our problems. So now, let's look up to it then. We take 1 with 6 zeros lined behind it. We see the number of zeros in this number is 6. So we help ourselves writing it like this. Here we call 10 as the base and 6 as its exponent. And the number altogether is said as 10 raised to the power 6. Now, we observe the exponent says a lot about the degree of zeros in the specific number. To learn more about this, let's take another number. Now, all we have to do is count the number of zeros, write it as a power of 10, and we are done. So we see there are 12 zeros in this number, which makes us write it as 10 raised to the power 12. Now, this collectivism of such a large number to its power is nothing more than multiplying the same number the number of times its power is. That is, writing the previous number as 10 raised to the power 12, we just multiply the number 10 12 times. Obviously, even if we take a relatively smaller number, let's say 4, and multiply it with itself 3 times, the same phenomena runs by. Again, no one could stop us from writing it as 4 raised to the power 3. So, you don't need to fear these exaggerating exponents at all. Okay, so let's move forward. Now I'm sure you people might have learned the process of expanding a number in lower grades. Now why I'm asking this is because we can pump our dear exponents into it. Let's see how. I am taking this number 1983, which when expanded can be written this way. Now we can simply write this alternatively in this form too. Now what we have done here is we just switch to the exponents, writing 1000, 100, 10 and 1 as per their respective powers. Now before you all might shoot me up of how dare I write 1 as 10 raised to the power 0, I must serve your query with the suitable answer. As I told you guys previously that the power of a specific number is just another way of saying that how many times that number has been multiplied. Like 10 raised to the power 3 is 10 multiplied 3 times. Now similarly, take 10 raised to the power 0. Now by convention, this means that 10 is being multiplied 0 number of times. Now, what does the power 0 imply here is that 10 is never going to stand a chance in its multiplication. Or we could say that it is not at all getting multiplied. So in order to prevent 10 from getting multiplied with any number, we assign it the value of 1, which apparently has no effect on the number with which it is to be multiplied. Hence, 10 raised to the power 0 equals 1. So I hope you must have grasped and understood why we helped ourselves writing 1 as 10 to the power 0 in this expansion. Because we never wanted 10 to get multiplied to 3. And if you might have noticed, our prime objective had been simply to write the expansion in the decreasing powers of 10. Now we'll be continuing with certain laws of exponents which would further help us perform operations with them in the very next video. You may leave your suggestions or queries in the comment section or drop them in my email. And if you found this video helpful, please don't forget to like and subscribe. This is Ritika from BloomWithMaths signing off. Keep blooming!